you through how it works, what it does, and why it matters. So every day, businesses collect a lot of data. For example, sales record, customer information, transactions, and etc. But having data is not enough. Um, so like questions arises like, what will happen next? Will this customer leave our service? Will this customer buy our service again? Will this sale be successful or something like that? So without the right tools, it is very hard to answer these questions. That is the problem that I wanted to solve using this foreteller. So what is foreteller? So what is foreteller? Foreteller is a predictive analytics platform. In simple words, it is a tool that learns from past data and then predicts future outcomes. A user can upload any data set, um, upload, can upload any data set, choose what they want to predict, and the system will do the rest automatically. No coding is needed. Um, no technical knowledge is required. Just upload, click, and get the result. So let me explain how the system works. Oh, pipeline report processing. So the user the user uploads a CSV file through the sidebar. This is the business data they want to analyze, like this one, customer churn data set, testing master.csv. The system automatically cleans the data. It fills in missing values, converts text into numbers, and scales all the values. Um, so the models, so the models can understand them correctly. So um, three machine learning models. Three machine learning models are trained at the same time. These are KNN, SVM, and ANN. Three different approaches to making predictions. The system shows the performance of each model, including wait, um, sorry. The system shows the performance of each model, including accuracy. This is accuracy, F1 score, and confusion matrices. How many predictions were right versus wrong? So the the user can choose the best one. So let me talk a little more about this, the pre-processing, the data processing, because I think this is the most important part. Real world data is usually messy. There can be missing values, columns with the wrong data type or wrong data, or text um, needs to be converted. Our pre-processing modules, um, all of this automatically. So this our pre-processing module handles all of this, like all of the data automatically. So missing numbers are missing numbers are replaced with the median value. Missing text is replaced with the most common value. Text categories like yes or no are converted into numbers using encoding. ID columns. Um, ID columns are removed because they are not useful um, because they are not useful for prediction. Then all features are scaled to the same range so that no single feature dominates the model. This step makes sure that the data is clean and ready before you use it or before the training begins. Now, let me talk about the three models that we use. Let me talk about the three models that we use. The KNN, KNN. This model looks at the closest data points to make a prediction. It is simple but effective for many types of data. The SVM vector machine, the SVM vector machine, this model finds the best line or boundary to separate two groups of data. Um, we can use a faster version called this, the linear SVC, which works well for larger data sets. The ANN, or the artificial neural network, this model is inspired by the human brain. Um, it has layers of connected nodes that learns patterns from from the data or information. So all three models are trained and evaluated at the same time. If the dataset is very large, for example, it has 30,000 rows or 50,000 rows, the system uses a sample to keep the training fast. After training is finished, the application shows the result in a clear and easy to read format. For each model, the user can see the accuracy, how often the model was correct, precision, precision when the model predicted yes, how often it was right, recall how many actual yes cases did the model find, F1 score a balance um, between precision and recall, uh, training time, how fast the model learned. There, there is also the confusion matrix for each model. This shows exactly how many predictions were correct and how many were wrong. This one, confusion matrices. This helps the user understand not just how well the model works, but where it makes mistakes. The application is built using Streamlit. Uh, this is, so that's why I typed earlier the pym Streamlit run app.py. It is using the Streamlit, which makes it easy to create web interfaces in Python. So this project doesn't have a HTML or it doesn't use HTML or CSS or any front end programming. It's just pure and um, Python and Streamlit. The design is clean and modern with dark theme. Then sidebar on the left is where the users upload their file and choose their target variable. Everything is organized so that someone without technical background can use it very easily. So this is the let me upload another one. This right here doesn't really do anything. It's just like it's just a column.
These are just the column that's been extracted from the dataset. So payment delay, subscription type, contact length. So we choose churn, then run predictive pipeline.
Um, as you can see that the system the system quickly process the data, train the models, then display the result because this data set was quite large. So for the sake of this presentation, the data set has only used this this project only used um, the limit of 10,000 data because if we run train all the data inside this CSV, it will take approximately, even with the GPU, it will approximately take at least 30 minutes. So it will take quite a long time. Churn. We can see that the AN model has the highest accuracy, 99.01%. It gives the highest accuracy. In this example, the conclusion messages below show where each model performs well and um, where it struggles. So to summarize the key features of automatic data cleaning, it uses three machine learning models: the KNN, the SVM, and the ANN. Accuracy, it has metrics like accuracy, one score confusion matrix, fast processing, smart sampling for large data sets. It can be adjusted if the user, although the adjust part can only be done if they have the source code. But yeah, easy to use, no coding required, just upload and click, basically plug and play. Um, of course, building this project was not always easy because the other course was also asking for a full development of a machine learning aerial surveillance type of application. So all my time went there, starting from I think May 2nd, when it was posted. I started working on it because it was very hard. So one challenge was, yeah, one challenge was dividing my time to develop this and the other one. So the design of this thing is not that really good like before. It doesn't have that much into it. It's just like a basic plug and play. There's basically nothing in it. The table looks, to be honest, quite ugly as well. It does look ugly. So um, yeah, another challenge was handling different types of data sets. Every CSV file has a different structure, so we had to make sure the pre-processing was flexible enough to work in any situations. Another challenge was the training speed. That's why we made the training cut short. So instead of training it the full using the full data of the data set, we only set a limit of 10,000 just for the sake of this presentation because it will take absolutely long time even with the GPU. Yeah, like I said, like max of 30 minutes. So yeah, some machine learning models can be very slow with large data. We solved this by using faster model versions. Um, by sampling the data we needed. We also had to make the interface. Yeah, that's why we interface was so basic. choose the file, go below churn, run predictive pipeline, so that and print, print, so that the results are very easy to understand for even non-technical users. And through this project, I learned some things, quite a things. First is time management. I need to work on my time management because it wasn't really managed that well. Through this project, I learned that, yeah, like through this project and the other project, I learned that to build a complete machine learning pipeline, you need an actual raw data, and those raw data is actually big because the aerial surveillance machine learning that I built for to train, it has 15,000 images, and it took 5 gig just to train. So yeah, so I also learned the importance of the data pre-processing. A model is only good as the data it learns from. So yeah, but as it's the same thing as the other project, like the training data is actually very important. And I learned how to um, I learned how to make things easy, I guess. I learned how to present technical results in a way that is useful and very understandable in almost vanilla-like UI, just like made by a fourth grader or something. So in the future, I would like to add more features to Foreteller if possible. More machine ML models. Um, Change the UI, make it look professional, not this vanilla like UI. Data visualization are charts, graphs, and make those graphs and charts downloadable or exported to PDF or something. Um, so probably regression as well. So not just classification, but also predicting numbers like sales or prices. So I believe that Foreteller has a lot of potential to grow into more complete business